Hello everyone, my name is Prince Raj and in this video I will be discussing the topic switching. So switching is one of the most important topic in data communication and networking. In this video I will be discussing the definition of switching along with its types and what is the difference between its types. So let's start the topic with its definition. So definition of switching says that it is the process to forward packet coming in from one port to a port leading towards the destination. So switching basically means that we are sending or we are transferring data from one device to another device. So it originated from its root word that is switch. So switches are basically devices which are used to connect two or more devices. So switching is the process of the same that two devices are connecting it and we are transferring data from one to another one as per required. So in switching, when data comes on a port, it is called ingress, and when data leaves a port or goes out, it is called egress. In a communication network, there may be two or more than two switches depending upon the needs. So switches are basically divided into two categories. That first one is connectionless and the second one is connection oriented. So connectionless is defined as the data is forwarded on behalf of forwarding table. No previous handshaking required and acknowledgements are optional. So there is no need of establishing a connection before transferring data. We can send data and get acknowledgement and depending upon if we need it to get acknowledged or not. And the second one is connection oriented. So before switching data to be forwarded to the destination, there is a need to reestablish a circuit along with the path both endpoints. So in connection oriented, first of all we need to establish a connection. First the connection is established, then we can forward the data and ask them to forward their data from their side. So this is what happens when we are using connection oriented switching. So let's move to the next topic. So what are the switching techniques? So switching techniques are of three types. First one is circuit switching, second one is message switching, and third one is packet switching. Packet switching is also of two types, virtual circuit and datagram. So let's look at them one by one. So circuit switching. So definition of circuit switching is that when two nodes communicate with each other over a dedicated communication path, it is called circuit switching. In a circuit switching, there is a need for pre-specified route from which data will travel on and no other data is permitted. In circuit switching, to transfer the data, circuit must be established so that data transfer can take place. So in circuit switching, first of all, we need to establish a connection between two devices. And between this time, no other device is allowed to send data to any one of them, or you can say that no other device will get the data that is sent from any third party. So during the connection period, only that two devices will be allowed to communicate with each other. This technique was mostly used for telephone system. As in a telephone system, only two devices are allowed to communicate with each other during the time period of their connection. During that time, only that two devices are communicable to each other and no other third device is allowed to interfere their communication. or transfer of data. So in circuit switching, it goes through three phases. First one is establish a circuit. That is, we need to first of all establish a connection between the devices to communicate and transfer data. Second one is transfer the data, the transferring of data, and third one is disconnect the circuit. So when we disconnect the circuit is free and it can communicate with any third party. So it can transfer data to the third and it is free to transfer data. So let's move to the next topic. So this figure shows how circuit switching is set up. So first of all, links are established between two devices and the data are transferred between them. So this is how circuit switching works. Let's move to the next topic. Next topic is message switching. Message switching lies in the middle of circuit switching and packet switching. In message switching, the whole message is treated as a data unit and is transferred in its entirety. In a message switching, first the whole message is received, it is stored, and until the resources are available to transfer it to the next hop. If the next hop is not having enough resource to accommodate a large size message, the message is stored and the switch waits. So first of all, the message is received and stored until the resource is available. So just like in circuit switching, that no one can interfere the connection between any two devices that have established a connection earlier. Just like I am transferring data to my friends and no other person, just like a no third person can interfere our communication. So first two person will end their transfer process, then third one will be allowed to enter. So like that, when the one will be available to receive data, then only the message can be transferred. So during this period, other entities are blocked and only two entities are allowed to communicate. So message switching was overtaken by packet switching. And let's have a look at the drawbacks of message switching. Drawbacks of message switching. So first point says that every switch in the transmit path needs enough storage to accommodate the entire message. So we must have enough space for receiving the entire message at once. Second point is because of storage and forward technique and wait include until resources are available, message switching is very slow. This can be easily understand that if we have to store and forward a message and before that we need to wait for the resource for its availability, this will make the process very slow. So message switching can be said to be very slow. The next point is message switching are a solution for streaming media and real-time applications. So let's see the figure of message switching. So this figure shows how a message switching works. So let's move to our next topic, that is packet switching. Our next topic is packet switching. So why we needed packet switching? As there is already message switching. So in this point, we will see why we needed packet switching. So this point says that shortcomings of message switching gave birth to the idea of packet switching. The entire message is broken down into smaller chunks called packets. The switching information is added in the header of each packet and transmitted independently. So in packet switching, we broke the entire message into small packets, and then they are transferred independently with a header that is attached its front that it attached to it, and then it is transferred to its destination separately. So the next point is it is easier for intermediate networking devices to store small size packets, and they do not take many resources either on the carrier path or in the interval memory of switches. So it is very easy for intermediate networking devices. So it becomes easier when small packets are very easy to transfer as compared to large size packets, just like we transfer the packets in message switching. So in packet switching, it we are dividing the packets into small chunks and are transferring it, so it becomes very easy. So in packet switching enhances line efficiency as packet from multiple applications can be multiplexed over the carrier. Uh, Also, the internet uses packet switching technique. Packet switching enables the user to different data streams based on priorities. Packets are stored and forwarded according to their priority to provide quality service. So let's move to the next slide. So our next slide is in our next slide we can see the figure of packet switching. So how a packet is transferred from one, that is sender, to the receiver. So we are transferring packet 2 from the sender to the receiver. We can see that in the figure how it is transferred. So let's move to the next slide. So in this slide we will see the modes of packet switching. As we can see, there are two modes of packet switching. First one is virtual circuit, that is connection oriented packet switching type, and the second one is datagram, that is connectionless packet switching type. So in virtual circuit, before starting the transmission, it establishes a logical path or virtual connection using signaling protocol between sender and receiver, and all the packets belonging to this flow will follow this predefined route. So in a virtual circuit, a virtual connection is set up, and this connection is used for the transfer of packets. So next, virtual circuit ID is provided by switches or routers to uniquely identify this virtual connection. Data is divided into small units, and all these units are appended with help of sequence number. Overall, three phases takes place here. First one is the setup phase, second one is the data transfer phase, and the third one is the tear down phase. Second one is datagram switching. In datagram switching, each packet contains all necessary addressing information such as source address, destination address, and port number. In datagram switching, each packet is treated independently. Packet belonging to one flow may take different route because the routing decisions are made dynamically, so the packet that arrives at the destination might be out of order. It has no connection setup and tear down phase like virtual circuit. So as we can see that in datagram switching, the virtual circuit, we do not need any virtual circuits connection, and the data are sent in packets, and the decisions for the transfer of data's path is decided dynamically as and when required. So it may happen that the last packet may arrive before the first packet. So if after the packets arrived, we may arrange them. So this is all about the modes of packet switching. So let's see the next topic. So in this slide, we will see what is the difference between circuit switching and packet switching. So in packet switching, physical path between source and destination is required, while in a packet switching, no physical path is required. In a circuit switching, all packets use same path. So while in a packet switching, packets travel independently. In a circuit switching, uh, reserve the entire bandwidth in advance. So first of all, path is reserved for the transfer of data in a circuit switching, while this does not happen in packet switching. These do not reserve any bandwidth in advance. In circuit switching, bandwidth is wasted, while in packet switching, no bandwidth is wasted. In circuit switching, no store and forward transmission is needed or used, or we can say that required, while in a packet switching, it supports the store and forward technique. So next, we have come to the end of our presentation. So in this PPT, I have taken references from the sites such as Google.com and Geeks for Geeks, Tutorials Point, and YouTube. So this was all the end of our presentation. So thank you for watching this. Thanks a lot.